Hello, the students of HS First Year Science. First of all, I congratulate you all for your success in your HSLC examination, and also I welcome you all to our SS College. Owing to this pandemic situation, we have decided to take online classes instead of offline classes. I am Srimati Sukanya Choudhury from Department of Chemistry. Now, all of you are science students, so you should know first what is science. Now, science refers to a system of acquiring knowledge. Again, science involves a pursuit of knowledge covering general truths or the operations of fundamental laws. Science can be viewed as a continuing human effort to systematize knowledge for describing and understanding nature. For the sake of convenience, science is also subdivided into physics, chemistry, mathematics, biology, geology, etc. Now today we will discuss the first chapter, basic concepts of chemistry. Basic concepts of chemistry. So then we should know what is chemistry. Now chemistry is the branch of science that deals with structure, properties, interaction, transformation of a matter, and the energy changes accompanying these transformations. Chemistry also plays a vital role in our everyday life. Chemistry has helped us to meet with all our requirements that are necessary for the advancement of life, such as food additives, healthcare products, plastics, dyes, polymers, etc. Chemistry is important for the development of commercially important polymers and understanding their impacts on environment. Manufacture of fertilizers, insecticides, pesticides, drugs, soaps, alkalis, dyes, metals, alloys, and other inorganic and organic chemicals, including the new materials in chemical industries, made a big contribution towards national economy. Chemistry also helps to prepare drugs. That is, chemistry helps to the synthesis of many life-saving drugs, such as cisplatin and Taxol, which are effective in cancer therapy. Again, chemistry is also helpful for making plots, for giving us entertainments. So we cannot deny the necessity of chemistry in our everyday life. Chemistry was crucial for understanding the formation of ozone layer, and remains crucial to understand the environmental impact of many produced materials. So these are the different importance and scope of chemistry. Now, we know that chemistry is the science of matter, so we should know what is matter. Matter is anything that has mass and occupies space. That is, matter is the stuff from which everything is made. You know, samosa, that is shingara. Here, potato is the stuff. Then material. Any type of matter is material. So from this, we can say that cement, paper, glass, these are materials. And book, pen, these are metals. So we can say that all materials are matter, but all matters are not materials. So this point should be noted. Next is, matter is divided into three phases: solid, liquid and gases. And you know that liquid is the intermediate form of solid and gases. So solid, these particles are held very close to each other in an orderly fashion, and there is no much freedom of movement. And in case of liquids, the particles are close to each other in an orderly fashion and they can move around. And gases, these particles are far apart as compared to solid and liquid, and their movement is easy and very fast. So, next we will come to classification of matter. Here, matter is subdivided into pure substance and mixture. Then pure substance is again divided into elements and compounds. Again, element is divided into metals, non-metals and metalloids. And compound is divided into inorganic compound and organic compound. And the mixture is divided into homogeneous and heterogeneous. So, mixture is whenever two or more substances mix together in any ratio. This is very important. In any ratio to give mixture. So, a mixture can be homogeneous or heterogeneous. Now, homogeneous mixture, a mixture having uniform composition throughout. For example, salt solution, sugar solution, etc. Now, heterogeneous mixture, a mixture in which the composition is not uniform throughout and different components can be observed, is called heterogeneous mixture. For example, cereals and pulses, etc. Next is pure substance. So, they have fixed composition and their constituents cannot be separated by any physical methods. Example, gold, silver, etc. Now, a pure substance is subdivided into elements and compounds. Now, elements. An element is defined as a pure substance that contains only one kind of particle. Suppose hydrogen, H, nitrogen, oxygen, carbon, sulfur, all are elements. Then compounds. What is compounds? A molecule of a compound is formed by the combination of two or more elements. For example, H2O, water is a compound. In H2O, two atoms of hydrogen combines with one atom of oxygen to form one molecule of water. Similarly, H2O2, you know hydrogen peroxide. This is also an example of compound. And in H2O2, 2 atoms of hydrogen combines with 2 atoms of oxygen to form H2O2. Next is our common salt, and I think you know the common salt, NaCl. So 1 atom of sodium combines with 1 atom of chlorine to form 1 molecule of NaCl, and this NaCl is also an example of compound. And the next one I can mention baking soda. Now NaHCO3, sodium bicarbonate, is also an example of compound. Next is elements are subdivided into metals, non-metals and metalloids. Now metals are those elements which reflect light and hence possess luster, and they are also good conductor of heat and electricity. And the examples are silver, aluminium. Next is non-metal. They are those elements which do not reflect light and they do not possess any luster, and they are brittle and they are poor conductor of heat and electricity except graphite. So the next one is our metalloids. Metalloids are those elements which possess the characteristics of both metals as well as non-metals. And the examples are bismuth and antimony and so on. So the compounds are again divided into organic and inorganic, and the inorganic compounds are of mineral origin, and the organic compounds are of plants and animal origin. Next is properties of matter. So there are two types of properties, physical and chemical. Those properties, so physical properties are those properties which can be measured or observed without changing the identity of the composition of the substance. For example, boiling point, melting point, odor, color, these are the physical properties. And chemical properties which require a chemical change to occur for their measurement, for example, acidity, basicity, etc. Now, we know that several properties of matter like length, area, volume, these are quantitative in nature and are called physical quantities. In order to measure the physical quantities, some standard reference is required. So we can say that a unit is defined as the standard or reference, or that is, it is the so a unit is defined as the standard of reference to measure a physical quantity. Now each physical quantity is represented by a number followed by a unit in which it is measured. So length is measured in centimeter and mass is measured in gram or kilogram. Then there are in old days there were two different systems of measurement. One is English system and the last one is metric system. And the metric system was originated in France and more convenient. So nowadays the SI unit is widely accepted, that is Système International. And there are 7 basic or fundamental units. And from these fundamental units, we can also derive various units. Now, length, mass, electric current, thermodynamic temperature, amount of substance, and luminous intensity. These are the 7 physical quantity. And meter is the SI unit of length, kilogram is the SI unit of mass, second is the SI unit of time, ampere is the SI unit of electric current, Kelvin is the SI unit of thermodynamic temperature, mole is the SI unit of amount of substance, and candela is the SI unit of luminous intensity. And by using these, we can also derive various units, and these are known as derived units. So area. So we can derive this unit of area by using the basic unit. So area is square meter, that is m square. Volume is cubic meter, so it is meter cube. Now what is density? We know that density is mass per unit volume, and the unit of mass is kilogram, and the unit of volume is meter cube. As it is mass per unit volume, so the unit of density will be kg meter per cube. So in this way, we can also derive the unit of velocity. Velocity is distance per time, and distance per time. So distance is meter and time is per second. So the unit of velocity is meter per second. Suppose acceleration. Now acceleration is velocity per time, that is meter second per square. Next is force. Force is mass into acceleration. So mass is kilogram and acceleration is meter per second square. So the unit will be kg meter per second square. Now the important thing is pressure. Pressure, we know the definition of pressure is, do you know? Force per unit area. So force is kilogram meter second per square divided by area, that is m square. So ultimately we get kilogram per meter second per square. So these are the different derived units. Then there are some prefixes, that is some physical quantities are either too small or too large. To change the order of magnitude, these are expressed by using prefixes before the name of basic units. Suppose 10 to the power minus 1, then it will be deci. Then 10 to the power minus 2, then it will be centi. Then 10 to the power minus 3, it will be milli. 10 to the power minus 6, it will be micro. 10 to the power minus 9, it will be nano, in this way. Similarly, 10 to the power 1, it is deca. So 10 to the power 2 is hecto, 10 cube is kilo, 10 to the power 6 is mega, 10 to the power 9 is giga. So in this way, we can use prefixes. Next is, there are some physical quantities. Suppose mass and weight. Now mass is generally denoted by small m, and it is the amount of matter present in a substance, and it remains constant for a substance at all the places. Its unit is kilogram. But weight is the force exerted by gravity on an object, and it varies from place to place. due to change in gravity, and its unit is Newton, capital N. So we can write that small w is equal to small m into g, where m is equal to mass, w is equal to weight, and g is equal to gravity. And volume, all of us know that volume is nothing, the space occupied by matter is called volume, and volume we can denote the unit by m cube. Next is density. Density we know, mass per unit volume. Then temperature. Temperature is defined as the degree of not only hotness, it is defined as the degree of hotness or coldness. Several scales are used to measure temperature. One is centigrade scale, one is Fahrenheit, and the last one is Kelvin, and Kelvin is the SI unit. So these are some physical quantities. Next is uncertainty in measurement. In the study of chemistry, we deal with the experimental data as well as the theoretical calculation. So there are several ways by which the numbers are handled conveniently and the data is presented realistically with certainty to the possible extent. And these things you better understand in your practical room, that is either in physics laboratory or in chemistry laboratory. Next one is scientific notation. Scientific notation. So scientific notation is the greatest way to represent any small or very large numbers conveniently. So in scientific notation, any number can be represented in the form capital N into 10 to the power n, capital N into 10 to the power small n, and where this small n is an exponent having positive or negative values, and capital N is a number called digit term whose values varies from 1.30 to 9.999. So the number of places, that is the decimal point has moved, is the exponent of 10. So it is positive when it is moved left and it is negative when it is moved right. Now suppose 943.876. So this can be written as 9.43876. So 9.43876 into 10 to the power 2. So is it clear? Similarly, we can also say that if the number is 15742, 1574228, 1574228, 1, 2, 3, 4, 5, 6, 6 digit. We can write it 1.57428, that is 5 digit. 1.57428. So 1, 2, 3, 4, 5 into 10 to the power 5. Is it clear? So similarly we can write 0.30968. So we can write, it is moved to the right. So we can write 9.68 into 9.1234. So we can write 9.68 into 10 to the power minus 4. we can write different types of numbers by using scientific notation. So you remember, if the number is 157428, we can write 1.57825. There are 5 digits, so into 10 to the power 5. So in this way, we can write different scientific notations. So this much for today. Thank you.